So we've learned about law signs, which law signs is really easy. You just have a fraction equals another fraction and cross multiply. But there's certain situations where you can't do it because you have to have at least one side and the angle across from it. So if we only know two sides and the angle between, so like we just knew C and B and angle A, we couldn't do it. Also, if we just knew side lengths, we couldn't do it. So there's another law, formula called Law of Cosines. And it should look, if I covered up this part, almost like Pythagorean theorem. A squared plus B squared equals C squared. It really is kind of like Pythagorean theorem with an adjustment. So there's a little bit of an adjustment because it's not a right triangle. Now the basic formula of this has C squared on the left. So we would use this if we were looking for side C, or if we knew angle C, we would use that formula. But depending on what we know, there are three actual formulas. So it depends on what you know as to which one you use. So if you were looking for side A, you would maybe use this one. Side B, you maybe use this one. It depends on which angle you know or which angle you're looking for also. So I'm going to write down all the other versions on my paper here, copy those from the formula sheet. So we have C squared equals A squared plus B squared minus 2. Now notice those are the A and B there, times the cosine of the angle across from that side. So if this was A squared, then this would be B squared plus C squared minus 2BC cosine of angle A. If this is B squared, then this would be A squared plus C squared minus 2AC cosine angle B. So Pythagorean theorem really is almost a special case of this. Or you can think of law of cosines as a modified Pythagorean theorem. So let's say we only knew the sides of a triangle. Okay, so we only know the sides. I'm going to draw my little picture. A, B, C. So little a is 5, little b is 8, and little c is 12. Now I can use any of the formulas I want, so I'll just use the one that was at the top. C squared equals A squared plus B squared minus 2AB times the cosine of C. I'm going to fill in everything I know. So let me I was looking for a specific pen. Let's use this one. So C is 12. A is 5. B is 8. So I'm going to fill in A is 5. B is 8. And I don't know angle C. So this one's going to help me find angle C. So 12 squared, that's 144. Then equals 25 plus 64 minus 2 times 5 times 8, that would be 80. Cosine C. Now be really careful here. Some people try to add these together and then subtract the 80. We can't do that. What I can do, though, is subtract the 25 from each side and subtract the 64 from each side. So 144 minus 25 minus 64, I get 55 equals negative 80 cosine C. Now, to move that negative 80, we would have to divide both sides by negative 80. So I have 55 divided by negative 80, which is, let me grab my calculator, 55 divided by negative 80, I get a decimal here. It's negative 0.6875. Okay, so I've got, let me just kind of arrow over negative 0.6875, and that's what equals cosine of C. So I want to find that angle C, so I'm going to do arc cosine, or A cosine of negative 0.6875. And that's going to give me angle C. So I'm going to do shift cosine, and you can just press the answer button, and I get 133.4. I'll just go one decimal space. 133.4. Now, as soon as I know one of those angles, and I know the side across from it, I have little c. Now I can go back to law of sines if I want. Sine of big A over little a equals sine of big C over little c. And I'm using C because we know angle C. So sine of big A over little a equals sine of big C over little c, which was 12. And I'm going to do some cross multiplying, and I end up getting 0.3027 equals the sine of A. Remember, to find the angle, we would do arc sine. And I get that A is 17.6. So now I know two angles. To find the third one, it's super easy. We just do 180 minus each of those. And this will give me angle B, which ends up being 29 degrees. Example 2. A tunnel is to be built through a mountain. To estimate the length of the tunnel, a surveyor makes the measurements as shown. So they couldn't really measure straight through the mountain, but they could measure the distances to each of the sides of the mountain and find that angle. So if this is big C, then this little side over here is little c, and that's what we're trying to find. Well, if I'm trying to find little c, I'm definitely going to use the one that starts with c squared. So A would be the little side across from big A, so that's 212. And B would be the side across from big B, so 388, minus 2 times A times B times the cosine of C, and we actually know angle C. Well, this is super nice because all I have to do is type in that left side. So 212 squared plus 388 squared minus 2 times 212 times 388 cosine 82.4. And so I get that c squared equals 173,730.2367. But that's what c squared equals. So I'm going to take the square root, and I'm going to press the A and S button. And now I've got 416.809, so that'd be 81, and that's in feet. Example 3, and I didn't give a lot of room there, but we can do it. So we've got triangle. I know angle A. I know, let's see, big C. I know little b. And I know little c. So the first thing I think I would try to find, since I know angle A, I would use the formula that has angle A in it. So I would find little a. I would use this formula. So I'm going to plug in what I know. And we get what a squared equals. Take the square root, and now we have little a. Now, once I have an angle and the side across from it, I can go back to law of sines. Sine of big A over little a equals sine of big B over little b. So I would plug in what I know. I'm trying to find angle B now. So I would come off to the side, do a little cross multiplying, and get 0.577 equals the sine of angle B. To find the angle, we would use the A sign or arc sign, and I get 35.3 degrees. Now it's super easy once I know two angles to find the last one. So 180 minus 46.5 minus 35.3. And so I get that angle C is 98.2 degrees. Now, we also tend to use law of cosines a lot when we have navigation. So in navigation, we talk about a direction as a bearing, and that is the acute angle measured from due north or from due south. So this bearing is headed up, so that's headed in the north direction, but 30 degrees to the east. So starting at the north, 30 degrees to the east. This one is starting north and going 60 degrees toward the west side. So north, 60 degrees west. This angle is down below the mid-axis. So I'm starting south and then 70 degrees to the west. South, 50 degrees to the east. So our example 4, a pilot sets out from an airport and heads in the direction of north 20 degrees east. So if I was thinking about here, that would be north 20 degrees east, would be going 20 degrees in this direction. And he goes along flying at 200 miles per hour. After 1 hour, he makes a course correction. So he goes here and he gets to this point, and at that point he starts heading in the direction north 40 degrees east. So I'm going to make another little cross. North 40 degrees east. So that would be a little bit more. This would be 40 degrees east. And he keeps going in that direction for a while. So he traveled in this direction for 1 hour, so this would be 200. He heads in this direction for half an hour. So he's still going the same speed, so this would be 100. And he has engine trouble. So we want to find the distance between the airport and his final location. So I know this is really hard to see, but I'm going to connect these dots. Okay, so my picture is really bad. Okay, so if this is 20 degrees, then this little angle would be 20 degrees. This one would be 90. And if this is 40, then this is 50. So let me redraw that triangle a little bit better. 20, 90, and 50, that would be 160. This was 200. This was 100. And we're looking for this distance here. So I'm going to call this little b and this big B. And you would use b squared. So you would plug in what you know. Now I'm not going to worry about part B. I want to go to the other part of this lesson. And this is a special use of law of cosines. It's how you can find the area of a triangle from just the lengths of its sides. So Heron's formula, which is on your formula sheet, says we take the square root of s times s minus a times s minus b times s minus c. S is half of a plus b plus c. It's called the semi-perimeter. It's just half of the perimeter. So if I have these three sides, and I was trying to find the area of the triangle, I would first find half of the sum of all the sides. So 5 plus 8 plus 12. Well, that would be 25, so half of that would be 12.5. Once I have what S is, I would plug that in to the formula. So 12.5 times 12.5 minus 5 times 12.5 minus 8 times 12.5 minus 12. And we would just plug that straight in the calculator. So I'm going to go off to the side and plug that in the calculator, and I end up getting the area is 14.524. I have one more example of using that area formula. So a businessman wishes to buy a triangular lot in a busy downtown area, and here are the dimensions of those sides. So the first thing we would do is find our semi-perimeter. And I end up getting 360 for that. So the area would be the square root of S, then S minus one of the sides, then S minus one of the other sides, then S minus the last side. And it really doesn't matter which order you put them in because they're all getting multiplied. And when I put that in the calculator, I end up getting a very, very, very big number. And that is feet, and it's area, so feet squared.